Assalamualaikum warahmatullahi wabarakatuh. So in this video, we will have a look at topic 8B on the title of per unit analysis of three-phase systems. So this is the learning outcomes. So after completing this unit, you must be able to apply the per unit method to analyze three-phase system. So we have a more specific discussion on the three-phase balance system, and this is the introduction of the topic. So we learn how to analyze complex three-phase system using per unit method. So the power system is to be analyzed is represented by a single line diagram. So this is at the end of the keyword. So that shows the various electrical components present and their interconnection. So we do have the generation side consisting the generator set, and we see how we analyze the impedance of that particular generator, and then we move on to the transformer, for example, the step-up transformer, and having its own impedance and the voltage ratio. And then we move on to the the transmission lines, for example, okay, and then another transformer as well as the load. So all these electrical components will be interconnected and represented in this single line diagram. So a key problem in analyzing power system is the large number of transformers. So somehow in a more complex power system, so we do have a large amount of transformer. So this will cause very difficult to continually have to refer impedance to the different size of transformer. Okay, this is the problem, the issue with the large number of transformers. So we have the problem once we come to the analysis, which side of the transformer, the impedance especially to be referred to. Okay, so we will see that by representing the transformer by their per model or the per unit models, so the analysis becomes very much simplified. It becomes much easier because the different voltage level, so the voltage ratio, for example, step up or step down, so this appear. So we are able to eliminate this voltage level difference. Okay? And then the overall system reduces to a closed circuit comprising interconnected impedance. All those components, okay, will be finally interconnected into impedance circuit in much simpler connection. Okay, to say that all the connection are in one simple series impedance connection or impedance circuit, which we call the per unit equivalent circuit. Okay, so the per unit conversion procedure. This is the what do you call it? The recap. How we can recap actually. So the revision of the per unit conversion procedure. So we first pick a three-phase VA volt ampere base for entire system S base. So this is the calculation for the three-phase. So now we have S base equal to square root 3 P base I base. Okay. So then the second procedure, the second step, so we pick a voltage base for each different voltage level, so called V base. Voltage are line to line. So this is an example on how we can pick the V base, or this is also known as VLL, line to line. So we calculate the current base is going to be the third process. So remember we are calculating in three-phase system, and then we have I base, and therefore we have I base equal to S base over square root 3 V base. Then finally we calculate the impedance base or Z base as well. So we have V base over square root 3 over I base. So the reason we have V base over square root 3 is because Z base is the line to neutral impedance. So it's a phase base impedance. And then divided by I. So we have I is actually from here. Okay, it's actually from here. So you take into this equation and substitute into this I base, and then finally we can have a much simpler formula where Z base equal to V base square over S base. Okay, so we have no problem with that since we have done so many analysis on this Z base calculation. And then the following step is converting actual values to per unit. Solve and we may necessarily convert back to the actual value. So work example number 1, 3-phase 500 MVA. So this is the value again for the parent power, the power S. So 22 kV. So this is the B generator has winding reactance of 1.065 ohm. So this is per phase. Okay, find its per unit reactance. So the XD equal to 1.065 ohm. Okay, this is the symbol for the generator. Once we convert into per unit equivalent circuit. So this is the DXT, the winding reactance. Okay. So next, so this is from the rating value of the given information. So we have 500 MVA. So the base voltage VLL 22 kV. Right. So the base current I base, again back to this equation, we have S base over square root 3 VLL. So 500 meg on 10 to the power of 6 divided by square root 3, 22 K. Okay. So giving the I base current of 13.122 kilo ampere. So what about the Z base? So the fourth quantity. So this first quantity we have calculated, the second quantity we have obtained, as well as the third quantity. Now we come to the the fourth quantity, which is a Z base. So Z base equal to V base over square root 3, so all together divided by I base. Okay, so now the Z base value is 0.967 ohm. So giving the XDPU, okay, the per unit reactance, so actual over Z base. So this is the information of the per unit reactance available in the question over the Z base we just obtained above. Okay. Now the per unit value in PU is J1.1002 per unit. So second work example, so a 350 mega VA. So this is again the S value. So this is the voltage ratio. This is a step up. Sorry, this is a step down transformer. So we have 230 kV down to 20 kV. So transformer has leakage reactance of, again, this is the value of reactance J10. Alright, so we have J10 over here for the leakage reactance. What is its value in ohms? Okay. So again, once you convert to PU, so just simply divide by 100. Okay, so 100. So we're gonna have 0 or J 0.1 PU. So solution, the information given relates to the following models of the transformer. So we have 350 MVA, we have the voltage ratio 230 down to 20 kV. So we have the ZT, the transformer impedance of 10%, and now we convert into per unit model of transformer. Okay, look at this one. This is what I have explained above. So to find the actual impedance of the transformer, we first need to calculate its base impedance, right? Z B of the transformer. So the base impedance value will depend on which side of the transformer we choose to refer it to. So suppose we decide to refer the actual impedance to the primary side of the transformer, then V base equal to 230 kV. So this is from the voltage ratio. 200 kV is located at the primary side of the transformer. So we choose 220, 230 kV to be the Z base. Okay, and then due to that, so Z base equal to V squared base over S base, so 230 over 360, sorry, 350 MVA. So giving 151.143 ohm. Now we have done with the PU value, okay, over here. So we have done with the Z value, I mean the base value. Now coming to the ZT actual equal to ZTPU multiplied by base. Alright. So giving us the ZT actual is the 15.1143 kilo. Okay. And then once you look at the PU equivalent circuits, now the ZT is located at the primary side because we have decided that earlier to refer the transformer to the primary side of the transformer, okay, of the unit. Now ZT is located at the primary side of the transformer. Alright, so it's very clear cut over there. Or alternatively, what if we decide to refer the actual impedance to the secondary side of the transformer? Okay. So then we have to pick V base equal to 20 kV. So we go back to our diagram. So we can see from the ratio, or we can see from the question, that the secondary side is having 20 kilovolt as the voltage rating. So from there, we can take and becomes the base or the V base. So therefore, so now substitute into this equation, so we get 1.143 ohm for the base. Actual, since we have ZTBU, okay, from the question, so this is the above calculation here, and then we might get the ZT actual once we refer the transformer impedance to the secondary side is now giving us 0.114 ohms. So now we have changed, or we have relocate the transformer impedance to the secondary side of the transformer. Right. So what about if we have a new base value? All right. So changing base impedance. So we have seen in previous analysis the value of the base, especially S and V, the power and the voltage, is fixed throughout the analysis. Right? But somehow the value might be different once one comes to another level of analysis. So equipment such as motors, generator, okay, and transformers, so the base, power rating, and voltage are typically used to calculate a per unit impedance. So we use the power rating. So this is the manufacturer rating. I mean power rating and voltage rating. So can be manipulated in order to come out with the PU impedance. Right? So, but in some instances, it is necessary to convert these PU values with different power and voltage bases to one common base. So the equation for converting a new impedance base is as follows. So this is a Z new PU. So the new impedance PU. Alright, so this is the old PU. And this is how it works. Okay, we have the V base old square. So we have the V base new, the one we select all right, or the one we refer to, and then we have the S, the power new, as well as the old SBs. Okay. So what example? So three-phase 50 MVA, so the megawatt ampere, so 3.3 kV synchronous generator with 10% impedance J10 or J0.1 PU is connected to a 100 MVA megawatt ampere 5 kV 33 kV to step up the ratio of voltage transformer as shown in the figure below. So find the PU impedance of the generator on a base of 100 MVA and 5 kV. So now we are having a new, basically a new VA as well as the both the V. And this is the illustration of the circuit or diagram, circuit diagram of what the question is telling you. So we have first again the generator as well as the transformer. So this is all the information you may get. Okay. So solution method one, direct method. So we try to avoid PU analysis in this method. So obtain the actual impedance of the generator and then convert it to the new bases. Okay. So we have all base quantities used by the generator. So V S base all 50 and V base all is 3.3 kV. Okay, this is from here. All right, the information is taken from here. Okay, so we do have 50 S for S and 3.3 for V. So therefore, so Z base all equal to V base all square over S base. So 3.3 kV, all right, over 50 MVA. Okay, so this is the value, this is the answer. Therefore, actual impedance of generator is, so we have a GPU, okay, this is from here, 10% or J0.1, so multiply by Z base all here, okay, so giving us the ZG H1, 0.0218 ohm. So now what about the new base quantity used by the generator? So the new one is actually from here. So the one I box or I write in box. Okay, so new S is 100 MVA and new V is 5 kV. So now convert everything into new S base as well as new V base. Okay, so Z base new over to equal to V base new squared over S base new 5 kV squared over 100 MVA. So this is the new Z base. Then therefore per unit impedance of generator on a new base. Okay, so new base, so we have VG new equal to ZG, ZG actual over Z base new 0.0218. So this is the VG actual divided by the base, which is 0.25 ohm. Okay, you take the new base over here. So giving us the value of new Z is 0.08287 PU, or in percentage, just multiply by 100%. Okay. So yielding ZG percentage equal to 8.7%. But if you used the equation or the formula introduced earlier, so the all base quantity used by the generator is given here. Okay, so this is the ZG all 10% on the two bases above based on this. Okay, so now we have a new quantities base used by the generator. Okay, here and here. Now according to this equation, so we have here is Z. Okay. So this is the generator impedance old. Alright, so remember. So this is V old. Alright. So this is V new. The base. All in base. So this one is S new. Okay. Oops, forgot the so you have to square it. This is a square. Alright. And then multiply by S new over base S base whole. Okay. So V base all is this one. Okay, so let me change the color. All this one into this formula. Okay, and then over V new V PU new is VB new, the V base new. Put it down. And then come to the S part, so the power part. So this is the base value new from here, okay, here, and then take the old value of S base, which is 50 MVA. Put it down. Then giving the value of 0.087 PU, and then in order to convert in percent, so multiply by 100%, okay, 8.7%. So this is much simpler, only one simple step or few simple steps in order to get a new ZG. Okay. Compared to this one, so you have 2 pages for example, so you have to use the old quantities to come up with the VZ actual before you can get the new V ZG actual. Alright, so the impedance of generator PU. Okay. And then work example 4.0. So the 100 MVA, 5 kV up to 33 kV. So this is lift the step up a transformer. So shown below has a leakage reactance of 7%. Here, all the information of the transformer is written here. So what is its PU value on 50 MVA, so 5 kV base, and then second 50 MVA 3.3 kV is. So it seems that we have a new condition. First we have a new value of V, and then second one also we do have a new value of V. Somehow S is remain unchanged. Alright, okay, this is again the information of the transformer. So we have the power over here, the V, as well as the Z, impedance ZG. So solution, transformer data, capacity. So the power capacity 100 MVA. So just put from here, right? So this is the step up ratio or the voltage step up ratio 5 to 53 kV. So the Z impedance percent 7% on 100 MVA base. So all base quantity of a transformer, sorry, all these become again the all base quantity. Okay, so the rating become the all value. Okay, all these are all. And then A, new base quantity for transformer. So we have S base new 50 and V base new 5 kV. So therefore, ZT new 0.07. This is old. Remember, this is ZT old over here. All right. So this should be taken from here. This is 0.07, right? And then this is the all V. So all V is taken from the transformer rating, voltage rating, okay, 5 kV. So over new base, voltage base, which is coincidentally same value. Okay, 5 kV. Then multiply by mu S, okay, over all S the power in base, of course. All right, so this is the new one, which is down here. All right, so here, and then this is 100 is taken from the old data. So 0.035 PU is the new ZT. So again, to get in percent, multiply by 100, 100%. Yeah, to 3.5%. So now the second condition, so we convert everything to new base quantity stated over here, S base 50 MVA and V base 3.3 kVA. This is all Z T. Okay. So Z T all again. So this is the all V. Right. This is a V new. So the old one is again from the voltage transformer rating. Okay. Put it here, and then since this is new, of course from question over here. Okay. So similarly for the S, so we have a new S. Okay, the base, the old S base. Okay, new. Again, this is from, of course, from the question. And then 100 MVA is from the thing from the old data of the transformer. 0.08 PU multiplied by 100%, so giving 5% ZT or the transformer impedance. Thank you very much for watching. So we will continue our example 5.0 with symmetrical fault to ground in the following video. All the best and enjoy.